Hi everybody. Second stress according to Chatelier principle. And to remind you, Chatelier principle is a principle concerned with the change in reaction equilibrium in response to a stress. The stress can be a concentration change, and this I explained it last video. And the second is a change in temperature. How the change in temperature affects the equilibrium and what is the behavior of the equilibrium reaction if that happens. Temperature change can be an increase in temperature, adding more temperature, or a decrease or removing of temperature. Increasing temperature will shift the equilibrium to favor the endothermic reaction. Why? Because usually when stress is applied to and to a reaction at equilibrium, the reaction will shift or will favor the direction which will consume this effect. So if the temperature is increased, the direction that consumes this temperature is the endothermic direction. You know that endothermic takes heat. So when temperature is increased, endothermic reaction is favored because it absorbs heat. While if the temperature is decreased, the reaction will favor the direction of the exothermic reaction to release more heat. To understand that, we need to differentiate between the endothermic and the exothermic reaction. The endo, from the part endo, it means internal. So it means in this reaction, the heat is taken into the system, is taken into the reaction. While exo comes from exit, the reaction is exit or released from the reaction, from the reaction medium to the surrounding. So endothermic reaction is a reaction that absorb heat, while exothermic reaction is a reaction that release heat to surrounding. We can consider that endothermic reaction, in endothermic reaction, heat is one of the reactant, while in exothermic reaction, heat is one of the products. You can think it that way. If it is endo, so heat is one of the reactant, you can treat it as one reactant, while exothermic, the heat is one of the product, you can treat it in the product, and you can look at it as we did in the concentration exchange. Also, it's very important to know about the enthalpy change. In endothermic reaction, there is a deposit of heat, so delta H will be a positive value. While endothermic reaction, delta H is negative value. Consider like a bank account. If you deposit money, so it will be added to your balance, positive value. If you take money, it will be deducted from your balance, so it will be negative value. So the bank of this reaction, the balance is heat. If heat is added in endothermic reaction, so it added to the balance, deposited, positive value. Delta H is positive value. While if exothermic, it is given outside the reaction, so delta H will have negative value. So you can know what is the type of the reaction simply from delta H or by seeing where is the heat is. But if you have a question without stating where is the heat is, whether it is in the reactants or in the products, you can simply look at the delta H value, whether it is positive or negative. So you can know whether this reaction is endothermic or exothermic by two ways. May you have the heat in the reaction, in the reactant, so it is endothermic, or in the product, exothermic. But if the reaction that you have in your question without stating the heat, what is the heat? You simply look at the delta H. The delta H value, the enthalpy change, positive, so it's endothermic reaction. So simply you have the heat in the reactant. While if the delta H is negative value, so this is an exothermic reaction, so you have to think the heat as one of the products. And to check which direction is favored, you have to look whether a reactant is added or a product is added in terms of heat. As I mentioned, endothermic reaction, the heat energy is one of the reactant. Think of it that way. That will be easy for you. So heat plus the other reactants will yield the product B, and delta H is positive value. While in the exothermic reaction, heat energy is one of the products, so the reactant, whatever the reactants are, will give the products and heat. To make it easy, you can think of it that way. First, when you know whether your reaction is endo or exothermic reaction, you can estimate whether your heat is one of the reactant or one of the products. And depending on that, if the heat is increased or added, the reaction will favor the reaction that consumes this extra heat. What is the type of reaction that consume heat? In the endothermic direction. While if the heat is reduced or removed, the reaction will favor the direction that produces more heat to compensate the reduction or removal of heat. And this type of reaction, the reaction that produces heat, is the exothermic reaction. So in that case, exothermic is favored. Consider the following reaction. A reactant A produces a product B and heat, and this reaction is at equilibrium. That means that if we look into the forward reaction, the forward reaction produces heat as a product, so it's exothermic reaction. While if you look to the reaction from the reverse direction, we will find heat as a reactant. In this case, it will be endothermic reaction. So here the forward reaction is exothermic from left to right, which is represented by this reaction. Reactant A will produce product B and heat. While the reverse reaction from right to left, it's endothermic. So heat is consumed as a reactant. Therefore, if heat is increased, what will happen? What do you think? If the heat is increased or raised or added, in that case, reaction will tend to lose this accepted or this increased heat. So it will take this heat and consume it. And in that case, endothermic is favored because endothermic will consume heat. But if the heat is reduced or eliminated, we expect that the reaction that produces heat, that produces more heat, will be favored. And what is the type of reaction that produce heat? Is the exothermic reaction. Okay, if heat is increased or added, endothermic direction is favored. If heat is eliminated or reduced, exothermic reaction is favored. To sum up, according to Chatelier, any reaction at equilibrium when affected by an external stress will favor the direction that relieve this stress. Last video we talked about the concentration exchange, and today we talked about the heat exchange. So if this stress is heat, the favored direction will depend on the type of the reaction, whether it is endothermic or exothermic. In general, endothermic reaction is a reaction that consumes heat, while exothermic reaction is a reaction that uh, produces heat. Okay, so if heat is added or increased, the reaction which consumed this increase in heat is favored, which is the endothermic reaction. With heat, when heat is removed or reduced, the reaction which will produce more heat will do the opposite effect. Is favored, which is the exothermic reaction. So the reaction usually favors the direction that oppose the stress, that is opposite to the stress. Thank you guys. Tell me your thoughts in the comments and tell me what you get from this video in short sentence. See you next video and bye bye.